Hi, I'm Ned, and I make games. This video is from my live stream over on twitch.tv/NedMakesGames, where I'm live Monday, Wednesday, and Friday at 9 p.m. US Eastern Time. I'd love to see you there. Alright, hey everybody. Hope you've had a great week so far. Well, I guess not so far, but basically the end of the week. But yeah, I guess a good Thursday and Friday so far. Yeah, I've been, today I've been able to just work on this grass project all day, so I've gotten quite a lot done since last stream. You can see now actually the grass has curvature, which is nice, and that's because I added a tessellation to the grass shader. So we can see here I can bring down the curvature. I guess 0 to make it straight, and then we can increase it. And it's hard to see here, but oh well, yeah, it's weird if it goes negative, but oh, what was I gonna say? But yeah, it's hard to see here, but actually there's less tessellation far away from the camera to do some LOD, and even with the tessellation on, the frame rate's still pretty good. It hasn't really dropped much from adding tessellation, so happy to see that. If I maximize it, doesn't pretty good. Although yeah, now I can hear my computer's fan running a bit. I do have OBS open as well, so that doesn't help. But yeah, so made quite a bit of progress. I also cleaned up the shader a lot by I moved a lot of, well, basically all this math into a separate file, so that way, because like I said before, I want to try and add a separate shader that will have like a height map built in, so that we can try to get it to work with Unity's terrain. So I tried to separate a bunch of this logic out, and then the soil shader is a lot cleaner as well. It just basically fills up these argument structures and then sends them to do the actual work. Let me think. What else changed? Oh yeah, I improved the LOD pattern. Before I did this kind of weird checkerboard thing that didn't really work too well, but now it's actually based on a dithering pattern. So we can, if you go in the scene, you can see, and you can affect this by, you can change the maximum LOD, and then yeah, the dithering pattern will change as well. So anyway, I was pretty happy with that. I keep on, I'm not sure if I want to have like the LOD radius expand, but I mean, if people want to do that, they can always add it themselves. But anyway, so pretty much the only things I want to add now are, I guess let me test this stuff again. So yeah, if we set this texture, it should, oh, we're not in play mode, so it's not going to update. That's kind of interesting. It doesn't update the mesh, but you can see it's decreased the height. Oops. Yeah, so it's based on the texture. Change some of the dimensions, and then on one side over here there's no wind because the wind power is also affected by this control pattern. Let's see. Actually, I created it in Substance Designer, so let's look at the texture real quick. So yeah, the red component is density. So we should see up in the corner, there's not as much grass. Oh yeah, so over here. That's because if there's low density, the shader will... Yeah, I'm surprised it doesn't show up here in our test thing, but the shader will like roll a dice and see if it's above the density, and if it's not, that just doesn't spawn anything there. Oops, I keep on pressing altitude instead of rotation. And then so the green and blue are width and height. So yeah, that's why the grass is longer in the middle of the terrain. And then the alpha channel is wind strength. So yeah, on the one side, the grass shouldn't be affected by wind as much. Although, yeah, so this side, I think, yeah, there's no wind. Okay, yeah, so over here, even though the grass is really short, there's still wind. So I'm glad to see that. I did it again. Okay, yeah, when you get pretty high up, the level of detail maybe breaks down a little bit, but... Oh, hey, Great Gowie. Thanks for coming by. How are you doing tonight? But I don't know, I think, yeah, if you're gonna see the grass from altitude, probably what you'd want to do is increase the LED radius at that point, so... Oh, great to hear. Yeah, I'm doing pretty good too. I got a lot of work done on this today, so I'm happy about that. Okay, so you can really see the border right there. I guess it's because the grass isn't very tall. I mean, I can see the border of the different LODs. So I wonder if I think I have oh no, I have dimension smoothing on. Okay, so that doesn't look like it's working. Yeah, I did rewrite a bunch of stuff, so okay, let's test this real quick. I'll put just a white texture back. And let's make this really simple. Okay. Okay. A bit too much grass, so I'm going to bring the blades per unit area down again and see if we can figure out why this stopped working. Oh, hey Nephilim. Yeah, we've got a lot of grass growing now. Okay, I want to turn off the curvature actually. I can just max bend angle. Okay, so that way we can tell. So I'm trying to fix See, they're just like, yeah, the dimensions, yeah, for every LOD level to kind of compensate for there being less grass, the width doubles. But the problem is you can see it like popping in and out. You can't really, you can kind of hide it sometimes with a ground texture, which we'll probably do, but I want to, it also should smoothly pop in and out instead of, or smoothly transition instead of just popping in and out like that. Thanks, Nephilim. Yeah, today I'd like to try to fix these bugs, and then I want to add, like make the graphic shader a little bit more fancy. So that's my goals for tonight. Alright, so we had this working the other day, so I'm gonna try to figure out what happened. Yeah, this was the right file. Okay, so we have this definition. Okay. Let's do... I'm just gonna write, to make sure that this keyword is actually working, I'm just gonna say if it's on, it will set everything to just 1. Okay. That seemed to work. Actually, no. Because, yeah, you can see... maybe it's just an illusion. But it seems like some of them are changing dimensions, but it might just be the twist angle, actually. Okay, let's make this really obvious. I'll just set the dimensions to 0. How about if it's on, and that way they'll just be hidden. Okay. So, I mean, I'm happy to see that because that means that this keyword is working correctly. But so it seems like these parts that are trying to smoothly transition between them aren't working right. I wonder when I change this, maybe I didn't pass like a fractional LOD or something. Let's see. So we have the LOD level gets returned from this function. So we got results LOD level. Okay, no, it's not. It's not clamped, or it's not floored, I guess. Let me... Okay, yeah, so the reason I was wondering that is because, like, I wondered if this fraction is always returning 0, which would explain, like, why this doesn't change anything with the actual dimensions. Oops. Yeah, it's looking for this file. So it passes forget dimensions. It passes the snapped position, dimensions and variance variables, and then the LOD level. So I think this is all correct. Maybe this dimension smooth start is set to a bad value. Well, for starters, I can make this a range instead of just a float. Just copy and pasting to make sure that the variable's named right. I'll do the same thing for the alpha, which I'll need to test as well. Oh, no, here. Okay, so that's starting at 0, which is fine because then it should just like interpolate over the entire lifetime. But it doesn't seem, yeah, it's still just popping in and out, which doesn't look particularly good. Let's see. All right, maybe one thing we can do is just color the blades based on this tint, and then we can pass like diagnostic information through the tint. Like I think we did that before with the LOD levels. Input tint. Or I guess we'll want to use the actual alpha, so that way we won't get blocks. Okay, yeah, so now it's just passing white because the tint color is white. So if we put something interesting into the tint, okay, how about we just put like the fraction of LOD and see what, to make sure that value is actually making sense. Okay, so they should. Okay, well, that's not what I was expecting. Maybe it's just because the alpha, correct number of arguments. Oh, this should be float 4. Maybe the alpha was like, okay, yeah, so that was better. But yeah, that's kind of funny because I don't actually, oh, the alpha of the tint is multiplied up here. Okay, so that's why it was invisible. But anyway, so it's all black, which is not what we want, because it should like start turning, or it should be white as we get closer to the transition. So this is the bug, I guess. For some reason the LOD isn't being set correctly. Okay, so what happened? So this LOD level, we said we pass it here. And it's just set to the minimum. So yeah, the distance between these positions, and then divides by the LOD radius. So I don't know why it would be clamped to the nearest integer, because that shouldn't be happening here. Because I purposely floored it and stored it in a separate variable. Let's... Maybe the maximum LED is like set to 0 or something, but that wouldn't make sense because it is doing LED levels correctly. Yeah, because we set it right there. Yeah, because when I change this level, it does affect the grass. Maybe... Okay, I was just checking to make sure I passed the right thing in. Do we accidentally set it somewhere below that and override it? Results. Okay, no. It's not really used. Let's see, what is that? What was that debug? There was that debug function that I could call that would color based on the LED level. I think it's, oh yeah, get index color. Let's just see what this gives us. Break this up. Okay, so we should get different colors for each LED group. Yeah, so that's right. So it is at least like counting the LED groups, but for some reason it seems like it's not keeping like fractional results in between it, which is a little weird. So that, I mean, I don't think that doing that swizzle should mess it up, but I guess I'll make sure. Okay. Always get into these weird bugs on stream. Oh, right. Well, we'll figure it out. I'm sure I've made a silly mistake somewhere. What about if I just cache the LOD level up here? If I can type. And in case like I do accidentally overwrite it somewhere. Okay, so now if we see shades of red, then we know for some reason it's getting overwritten. If we don't. That is pretty weird. Okay, so that means if it is getting overwritten, it has to be somewhere in here, but I already checked it. This will break all of our LOD stuff, but okay. I'm pretty sure it's get the fractional part of a float. You do call the frac function. Yeah, the fractional part. And it is afloat. Yeah. Okay, what if I... It's like manually recalculated this. Okay, so minimum distance. And okay, so the LED radius is this, and then the maximum is this. So this should still give us something. Okay, so that tells me something weird is going on in that structure. Yeah, this works how we want it to. Where it increases as we get to the edge of the LED radius. Okay, so it must gotta be getting overwritten somewhere in here. But what about if I do this? If I just recalculate the same thing here. Oh. Yeah, we can just use the... So we know that it's happening somewhere in the get or calculate grass cull function, so... Alright, so that means it must happen somewhere in this function. But we call grass LED last, and then... Does it like... Because I don't even change the value. What if I do something like this? Maybe this is a weird compiler problem. Which would be kind of annoying, but... Alright, so settings... LED radius... Okay, so if I just recalculate it here, does that work? Undeclared. Oh. No, that wasn't what I wanted to do. But it does work. If I if I did something like this. Or does it not? Well then, what about, okay. Oh, it's because I set this as an integer right here. Why did I do that? Okay, well that would explain it. Like I said, I knew it was a silly mistake, but we got there. Okay. So now I can get rid of all this. And... okay, yeah, so now it's working right. Oh yeah, it's already starting to do the dimensions fade. Okay. So if I bring this up, okay, it's actually working the opposite of how I wanted it to. When you bring this up, it should make the dimensions fade not start until farther down, but it's so annoying when it ends up being such a trivial mistake. I know, Sam Hedge. It's it seems like that's like, I don't know, 90% of the bugs I encounter, but you gotta get past it somehow. Okay. So anyway, so it seems to be working, except I... yeah, exactly. So the smooth step, I think I did some math incorrectly here. So at 1, yeah, we want it... so we actually want this to be 0 at when LOD fraction is 1. So we can just take away that inversion. So yeah, so I should have... so when this is 1, it should be 0, and then when this is 0... oh, okay. Let's see, now I think this is right. So now when this is 1, see here. So basically I want oh right, okay, I'm thinking about it the wrong way, I think. Yeah, it's not interpolation, it's smooth step. So yeah, if this value is less than LOD smoothing, then it's going to return 0, and then if it's greater than this value, it will return 1. So when this fraction, yes. So I think that right, and then I need to do the inversion there. Let's see. Yeah, that's better. So we can see that, yeah, when this is higher value, that basically they shrink, excuse me, they shrink down faster. You can see it in action. Yeah, and the only ones that shrink are the ones that are going to be cold in the next LOD level. Yeah, the other ones are supposed to grow slowly, but it's I think inverted again. Okay, so here it's the same thing except is that right? So basically we want to move up an LOD level in between. So actually I think it was right before, but it didn't look correct. It's kind of hard. I think it's the when it flips color, it makes it hard to see. But so basically when a grass promotes to the next LOD level without being culled, it should smoothly change width. But it's kind of hard to, I think that's what's happening, but it's kind of hard to see with the way, yeah, because since it changes color, it's kind of distracting. Oh yeah, but you can see on, watch this one right here. So it's red right now because it's about to promote to the next LOD level. Yeah, and then it grows to be the correct size, and then it turns black, which means it's in the next LOD. So it's working right, but it's just kind of, I don't know, it's a little distracting when the, I think when this dimension start is so high. Something like that. is a little better. It's really obviously, well, it's really obvious right now because the grass density isn't very high, but I think when we bring back the grass density, it won't be very obvious anymore. All right, so let's test this alpha. The same thing with alpha blending real quick. It's not, it's going to be kind of hard to do because right now we have alpha clipping, but I guess we can see. So basically the same math as here. So I need to not invert there, but invert here. Yeah, because the alpha should go down to 0 when the LOD is about to switch over. Okay, so we can test that out real quick and hopefully. So we'll just put it on 0. But yeah, it will be difficult to see right now because I have alpha clipping on. I'm trying to look for one that will disappear. Okay, so this one right here. But yeah, it just pops in because of the way the alpha works. But okay, so it already was at 0. I was gonna say if we have it at 0, there should be a little bit of a tell. Let's test it another way. I think I'll get rid of this test tint thing. It might be nice to have a built-in like LOD test mode, so maybe we can work on that, but it's not a huge priority at the moment. Okay, so then in here, let's just set the alpha to the color. All right, so we should hopefully be able to see. What is the clipping threshold actually? So, oh yeah, it's like 1/2. Let's do. All right, so I guess I'll just disable alpha for now and it'll just turn black when it should be invisible. I don't see any blades turning black, so yeah, and alpha smoothing is turned on. All right, so let's test if I set the alpha to 0, if it's going to be culled, then we should see some. Well, I guess they're going to pop in anyway, but yeah, that's not going to help us very much. Let's just, I think I'll just set this alpha always to 0. If this keyword is on, just to test to make sure the keyword is working correctly. Because I have it checked right there. Okay, so that keyword is not working, which I guess is good to know. So here, I have that. Did I? Oh, I didn't make a shader feature for it. Okay, so what that means, you have to add this line to tell the shader to compile a version of itself with this keyword turned on. This is not enough just to have this toggle there. Okay, so I'm pretty sure that's going to be the issue. Yeah, so now alpha is 0 because they're all black. If I turn that off, we should see it smoothly transition. Yeah, you can see some of them. It's not very smooth though. Okay, well, I don't know what's up with like only the outline showing. That's kind of weird, but it's doing something anyway. I forgot to check the little slider. So if we do this, it should start to transition only about 3/4 of the way. Yeah, which it seems to work. I don't know why it has to like, why only the border shows for a bit, but I'm not, it probably has something to do with the texture, so I'm not going to worry about it. Alright, so now if we take away that test mode, yeah, I think it, oh yeah, see, we do this. I think this is the reason that it was showing the border, because this is taking partial derivatives, so it's looking for changes in alpha. Yeah, so that's probably the reason. If I took out that line, I bet that we wouldn't get those borders anymore, but it's not super important. Yeah, so yeah, you can't really see alpha blending again because we have cut off, but you can kind of see it. This one is dithering slightly. I don't know if you guys can see that on stream. Let's see. I'm trying to look for another one that's more center that's going to disappear. But anyway, it's kind of a subtle effect. I think it would look better if alpha blending was on instead of cut out, but that's not trivial to turn on, so I probably should test it. But actually, yeah, alpha blending won't work with the way I've got everything set up, because you've got like the order that you render triangles is really important. So I guess, yeah, that's neither here nor there, but all right. So I'll leave on dimension smoothing. Because it works best with our current setup. Okay, so one other thing I was going to look at with LOD is that when you get high up... oh, what's going on there? Okay, something is weird with... camera custom culling, I guess. Let me see. I'll try it real quick, but I don't... I want to get to working on the graphic shader. So, I don't know if I'll fix that off stream probably, but let's see. So if I turn off custom culling, I'm just gonna see if that bug goes away. So I was rotating downward. Okay, so I guess that's good. Well, I don't know, because now I don't know what's causing it. Okay, so it's not frustum culling. Let's look in this scene. Does like the soil camera not know how to deal with the actual camera being rotated? Oh, the soil camera is moving below the ground. See, this the square is the soil camera, so since it's below the ground, it's not actually rendering any grass or projecting any grass. Okay, so probably the camera shouldn't move in the Z coordinate or the Y coordinate. Yeah, I guess so. Okay, so where is the camera manager? So yeah, it tries to snap. Okay, so that's, yeah, so it just sets the snap position to the follow Y position because we don't really, the cells don't care about the Y coordinate that much. I think instead I'll just have the Y coordinate not change. Of the soil camera. Yeah, so the Y coordinate will never change for the camera. Or the soil camera anyway. Okay, so I guess I could have turned custom culling back on, but anyway, so when we rotate downward, yeah, everything works as it should. Okay, so that's good. But anyway, so yeah, when you move up, you can see the LED levels pretty starkly. Do I care about that? Again, we do have pretty low density. Maybe I should make it so you can control the minimum density a little bit more. I think that would be the easiest way to fix this. Oh yeah, I wanted to turn back on frustum culling. Okay, so basically to do that, where I have this dithering alpha, oops, I can just have it have like a minimum. So float minimum dithering. Okay, so yeah, I already kind of enforced that. Okay, something like that, and then you can just add that as a input here. And then on the actual shader, we'll make setting there. Call input dot minimum LOD dithering. And then we just gotta add this to the shader. Oh. Okay, and this can be a range because it only goes between 1 and 0. Okay, so as I move this up, it just makes the last LOD more thick. And even though if you bring it up to a certain point, the LOD, like LOD 1 and 2, have the same dithering, they're still different because LOD 1 has more tessellation, so I'll leave it. Let's try that. I mean, you're always going to see a little bit of a border, but I think that is probably better. Sorry, something in my throat. All right, let's see. So what's next up? I think, yeah, let's go ahead and move to the graphics shader. And hopefully we can get that all set up, and then I can maybe work on the terrain, shader for the terrain. Let's turn. I was gonna say let's turn on curvature so we can see the tessellation a bit more. Go a bit. Make this a bit more pretty. A little bit. If you go too much, like the scatter makes things look better, but if you go too much, you can start to mess up frustum culling. Okay, I think that's fine. And then on our grass manager, we can increase the blades per unit area. Okay, well, that's really thick grass, but even still, yeah, I'm still getting around 600 frames a second with OBS. I'm really impressed with the performance of this system. I wasn't sure how well it would run. Yeah, so this is probably a better amount of grass. Even though you can see some of the ground, we can make a ground texture which will hide that a bit. Maybe we'll get to that today as well. I don't know if I'll include that in the tutorial because it's kind of tangential, but maybe. Alright, so anyway, let's work on the graphics shader. So I have this grass lighting that I've been working on in another project, and it kind of just adapts the URP lighting to work with like a more to just look better for grass, I think, because it incorporates like subsurface scattering a little bit. It's actually pretty simple because I turned off multiple lights. I guess I'll probably need to add that back in for the shader because I know people will want it. I think it does have shadows, so I should probably test it. But anyway, so in order to set this up, we basically just need to fill out the structure, and then these functions will do the rest for us. Okay, so lighting. Okay, and there's a bunch of different fields, so I'm gonna, I guess we can have a split screen here. Okay, so we've got the position, which is easy. We already have that figured out. And then the normal. Okay, so this one I want to incorporate a normal map. Yeah, so I already know I'm going to need a couple things here. So I'll have a normal map and then a sampler for it. And then I'm going to have a data texture, which will let me do things like specular strength and the subsurface strength. And then I'll want other stuff here. I guess the alpha cutout should go under the main texture. And then we'll have a float, normal strength. And then here I'll have a float, smoothness, and specular strength. I guess we can do one for subsurface strength as well. So I forget. I made a substance for this. I guess I'll go ahead and open up. Yeah, so here, oh yeah, smoothness, specular strength. Okay, I have ambient occlusion as well. But I don't think I need a property to change that. Okay, so anyway, so for the normal, first we need to, so I already have, I have this set up, which extracts the normal and unpacks it, applying the normal strength, and then we transform tangent to world, which okay, I already calculated tangent to world up here. Does my I don't have the sign bit, but I know it's going to be 1, so that's fine. Okay, so anyway, so we have all that to calculate the normal. Okay, now the shadow coordinate, we can use the same method that we did for normal lighting. Okay, the view direction as well. All right, okay, so ambient occlusion we'll get from our control texture, which, okay, I don't sample that yet. Okay, so control sample. Oh, I actually call it a data, the data texture, so maybe control's better, I don't know. Anyway, okay, so ambient occlusion was the red coordinate. Specular strength was, I think, blue, actually, because I think green is smoothness. Oh no, green is specular strength. Oh, and ambient occlusion is blue. Okay, so I got that all mixed up. Okay, so specular strength. And then you also need to multiply, or I want to multiply this with the specular strength. Property, geez, sorry. Yeah. And smoothness is next, which is the red. Okay, and subsurface strength is the alpha. And like, this is the main thing that's different than the normal lighting path is, and it tries to model like how light shows through grass, because you know grass is pretty transparent. Okay, I already did the shadow chord. Okay. Trying to do these in the same order that they appear in the structure. Alright, so then the shadow mask we don't actually use here. You can just set it to 1. This is for... Yeah, actually, we're going to need to add that to this shader if I use it. Same with baked GI, which is light maps and stuff. Probably, I bet people are going to want to use it, so maybe I'll try to figure it out. Okay, and then we can pass the alpha through. And then we just call calculate grass subsurface lighting, passing in this lighting structure. This comment is incorrect now. Yeah, I can get rid of that part. Okay, so I think unrecognized identifier. Oh, I didn't include the helper file. Yeah, so grass lighting. Oh, yeah, it needs a capital S. Is used without having been completely initialized. Okay, so what am I missing? Got position, normal, view direction. Oh, albedo. That's important. No, it's right there. Oh, I forgot. I didn't type the period. Okay, so create tangent to world implicit truncation of vector type. Okay, I think it's because the tangent must be a float 4, but I don't actually need it to be a float 4. So might as well save a little bit of work there. Vector type at 193. Oh, okay, so I actually convert it to float 4, but I'm not going to worry about that. Okay, so it's going to look weird right now because we haven't set up a normal map or a data. Oh, actually, it doesn't really look that bad. But anyway, so let's... we can use this as is, although I think one thing I wanted to do was blend the subsurface scattering with a gradient. So because at the bottom of the grass there won't be as much subsurface light because it will have been occluded by other blades. So let's add a linear gradient and then histogram scan, which is good to just get or control how the gradient looks. And then we can use this blend. Okay, let's go get rid of that. Okay, and then blend, we'll set it to multiply. And pass it. Okay, I had a... Yeah, what was that node called? Yeah, the RGBA merge. That's better than using a bunch of different channel mixers. Let's see. Okay, so this way I can just write that. The only thing I did, well, I guess it doesn't really matter, but it makes it hard to see what's going on because the alpha channel hides information, but I think something like this will look a little better. Okay, anyway, we can see how it looks in the game. So I'm just going to export this into a different folder than that. Okay, so now we should have it in Unity. All right, so yeah, this is the color texture. We want alpha to be transparent. Generate bitmaps, and be sure to have this bitmap preserve coverage, so that way the alpha channel doesn't like expand with lower bitmaps. We can set this to trilinear and wrap mode to clamp. Okay, so the normal map, we just set it to be a normal map, and I think the default settings are fine. I guess we can do trilinear here. Oh yeah, we also have to set clamp. And then the data texture is not sRGB, but yeah, also clamp and trilinear is fine. Okay, so now on our grass material. Oh, it hasn't updated because I didn't add any of these new properties to the shader. Move this over here. Okay, so we have the main texture, the normal map, and the data texture. Okay, so I guess what is it? It's smoothness, specular, ambient, subsurface. I think this is gonna be a bit too long, but okay, but that'll do for now. And then I need to add all these. I want to try to keep this organized. Oops. Okay, and then we've got normal strength. And smoothness, specular strength, and subsurface strength. I keep pressing the wrong keys. Yeah, my pop filter always gets in the way of view of my keyboard, which always brings to mind how much I need to practice not looking at the keyboard to type. Subsurface strength. Oh, I don't need to do. Shouldn't do camel case there. Okay, so now we've got all that set up. Okay, so we can set our texture. Okay, so I'll leave. Well, let's just leave all that how it is and see how it looks. It might not be that different, but okay. So it seems to be. Yeah, so specular. That's interesting. So the subsurface strength actually makes a pretty big difference, which I'm kind of surprised about because yeah, the normal, yeah, the normals are kind of okay. So the thing that's going on right now is that the normal map is making a big difference, but it's actually not set up correctly because right now the normal points along the terrain, but for this system we need it to actually point outwards from the grass's face. The reason for that is because, like, before we didn't do that because it's kind of a good, simple way to implement like subsurface scattering is if you just point the lighting normal straight up from the grass. But the only problem with that is that, as you can see, we don't really have any specular highlights, which is, I think, kind of a shame. If you... Okay, I need to... So it's obvious I need to try to work with the frustum culling a little bit more, but... What happened there? Oh, I think it just... So what I was gonna say is that sometimes when you have it set up like this, you see like just a big row of all the grass that's like has a big specular highlight on it. It's not that obvious on this grass. Don't really know why. Oh, maybe it's because I have specular lighting turned off. So yeah, that's probably it, because I have this grass specular on, so you can turn it on and off. I think I want to go ahead and define it. I'll leave that on. Okay, so now we should get specular highlights. And yeah, but it's probably going to look bad right now because it'll have... Oops. A big stripe. Oh, actually... Okay, well, you can kind of see it right here. So, like, all the specular highlights are kind of clumped together. The actual highlight, like, on the grass doesn't look too bad. Although it looks like... Yeah, it seems like the textures aren't matching up correctly, because you can kind of see a blade is like moving through the grass. So what's the deal with that? Oh, I didn't update the albedo texture. That's the problem. Yeah. Okay. Although it doesn't seem like alpha cutout works anymore. But anyway, so yeah, the like the specular highlight on the grass looks good, but it doesn't really make sense for it to just be in a clump. So yeah, in order to fix that, you have to change the way the normal vector works. Okay, so why is the alpha being like that? Oh, for some reason I had removed alpha from here. I was probably testing something. It's no problem, just re-export it. Okay, so yeah, that looks better, I think. But okay, so let's see here. Let me think. I think actually might not be too difficult to do. So right now, if we notice, so yeah, in the whole program, we already calculate a normal and a tangent, but this is the like pointing, the normal points upwards along the grass. So if I wanted, so outwards from the grass is actually the bitangent, which I don't calculate yet, but oh, actually, yeah, I get this. Oh, that's for wind. Let's this normal is I guess I'll rename this to the terrain normal, and we do need this because we need it for the wind to look correct. But so the tangent, or the grass normal, I think we'll point along the negative z direction in tangent space. And then, so in that case, the tangent will point in the x direction. Might need to flip that as well. I'll see. Okay, so I think this should give us better looking normal map. All right, let's get up close to one end. Really see. Do I still have the normal turned? Yeah, I have the normal strength off. Okay, so it does make a little difference, but only down there at the bottom, which is kind of funny. Oh, yeah, and also the bottom of it is cut off because of the way, yeah, I need to change the way I do alpha. So I don't want to have this little bit that helps blend into the ground anymore. Anyway, so what I'm trying to see is if I need to export. I'm trying to see if I need to flip the tangent vector. You can see. Seems to be all right. But yeah, I think I'll need to make a test normal map to make sure. So let's we'll test if I should reverse graphics shader tangent vector. So by the way, what else do I need to do here? Oh, I was thinking about that, but I'm not sure. I think this will be too difficult. Okay, so anyway. Yeah, so if you turn subsurface strength off, now the grass is going to black out because the normal vectors are basically pointing too far away from the sun to actually get any light. What's going on? I think I messed up. Oh yeah, I should rotate this around, but yeah. So yeah, we definitely want to keep the subsurface strength on. Although the only thing, I'm a little surprised that it's so dark. So what happens if I change the sun direction? Okay, that kind of makes sense. So the more it gets closer to horizontal, the brighter the grass lights up. Which makes sense because the grass vector is pointing like perpendicular to the ground or parallel to the ground. Alright, I still didn't really notice much specular light though. I guess so. It might just be... Oh, I mean, there was some before. Let's, run on, like, just test the specular. Okay, so this is right now just only showing specular highlights. Okay, so there's not any. Oh, there's a little bit right there. Do I have specular turned off or something? No. Oh, it could be the smoothness, I guess. Huh, that's kind of... Okay. I feel like something's wrong because... Yeah, if you have smoothness at 0, there should be quite a bit of specular highlight. Checking to see if I use the wrong variable name. Okay, I guess I did make a typo because now I'm seeing some. Yeah, there we go. You can see faint bits. But yeah, it's not everywhere because it depends on like where the sun is, so. Yeah, it's pretty weak, which is I'm kind of surprised, but let's see if I... So it gets a lot stronger as well when you move the light around. Okay. So, one thing one thing that's not the best about the current system is that when when the wind blows, it doesn't actually like affect the lighting at all, which is fine, but you can really, like, if you have a strong specular light, it's kind of obvious because the specular light doesn't shimmer with the wind, which you would expect. Yeah, hi Nephilim, thanks. Yeah, I feel like yeah, we are starting to get somewhere. But so there's one way that you can fix that, And the reason it's like that is because the normal doesn't get perturbed with movement. I feel like it's gonna be kind of expensive to calculate, but because basically what you have to do, I guess it won't be too bad. You need to like find out the wind or the position in world space for a small distance along the tangent and bitangent vector, and then you can calculate a normal based on that. So let's see here. So the position only changes based on wind. So thankfully we don't have to recalculate all this part, just this part. So let's make a function float 3 get wind offset. Oh. Okay, so what I need for this is position and so I don't need time. And I need the the wind UV, yeah, it's calculated that way. Okay, then I need the it's normal, and then I need a UV, or I guess it's a strength. We can multiply that together. Okay. I need to change that name real quick. Alright, so I could probably make this a little bit more efficient if I like calculated certain things like the time frequency and this cross product outside of this function, but just for ease of use. I don't think I will. Those kinds of like little optimizations I don't really put in tutorials because it just makes everything more and more complicated. So anyway, the actual position, we'll add get wind offset, and we'll pass in that and the terrain normal, and then this. Which I guess I can just, I'm gonna need this a couple times, so. Okay, so now what we have to do is calculate a position or the offset position for a small distance along the tangent, which I have here, and then also the bitangent, which is we'll need to multiply. Let me think. I think what I should actually do is calculate these, like the normal tangent this way, and then perturb the position based on this tangent, and then we'll go from there. I think that's a little easier, or will be the right way to do it. So float 3. I guess grass normal is that, and then grass tangent is this, and then the bitangent is, I think, the negative terrain normal. Because, yeah, actually, wait, the terrain normal and the grass normal. Oh. Yeah, that's incorrect. This should be... I'm surprised I didn't notice that before, because, yeah, the terrain normal points along the tangent space y vector. So the tangent space... Okay, so let me think. So tangent space... It's kind of confusing. For, like, spawning the grass blade, Z is pointing outwards from the terrain, but then we want to, like, the tangent space for the actual grass blade itself is pointing, like, parallel to the grass blade, or parallel to the terrain out the negative y, I think. Might be positive. I think I'll just leave it like that for now. Oops. And then, okay, so the grass tangent then, so it goes in the U direction, which is horizontal across the blade. So that would be also the terrain X direction. So this is right. So that means that the grass bitangent is just the terrain normal. So I guess we'll just copy that. I hope that makes sense. Maybe I should rename, instead of grass, maybe rename it to blade normal. Okay, so anyway, we have that. So we got the wind strength, and so now I need to get like the change in this wind offset position. So float tangent nudged equals I actually need to save this. So this will be float 3 final position world space. Yeah, because this is like the I think that's fine. Let's rename this to like the, I don't know, deformed position. Okay, so yeah, so this is the undeformed position plus the wind offset. And actually, I think the grass should use, or the wind should use this, because otherwise it's the entire blade is going to have the same wind vector, which I guess might be okay. We can see how it looks. Anyway, so then that means same thing here, except yeah, we offset this slightly by the blade tangent. Be pretty small value. And then we need to do the same thing for the bitangent. Okay. So, okay, so to find the actual blade normal, which I guess I didn't need here. Because, yeah, we're going to find it by taking the cross product of these. Okay, so float 3, blade, normal, world space equals tangent. So we basically need to find. I guess I don't need to add this here because we'll just do the cross product of this nudge amount. Is that right? Yeah, because this is the difference. Because if you have to like subtract this from. Oh no, I guess I need to subtract it from this position. So yeah, so we got to add this in so they all have the same origin. So anyway, so it's from the tangent nudged minus position world space. I forgot the cross. And then by tangent nudged. Okay, I hope I'm getting all this correct. All right, and then you need to normalize this for sure because they probably aren't orthogonal. Okay, so now we can pass this normal here, and then we can just use this tangent. Or wait, it's this tangent. All right. Okay, so get wind offset cannot complicitly convert from float 2 to float 3. Oh, yeah, I just want a float 3. Yeah, I guess that's fine. Cleans this code up a little bit. Okay, so let's see how it looks. Hopefully, yeah, the normals now should change with the wind. Which I guess is kind of hard to test, but some more frustum problems there. It seems like when you rotate a certain way, it doesn't work as well. Okay, well, one way we can tell if it's working is if I turn back on that specular test mode, because the specular light should only be, it should flicker in and out when as the normal moves. But I don't see any specular lights, so that's not a good sign. Okay. Probably made a mistake somewhere because we're juggling a lot of normal vectors here, so it's not super difficult to get things confused. Let's see. Why don't we just set the albedo as the or the normal vector as the albedo? Okay, so this normal ranges from -1 to 1. So in order for it to fit as a color, we just need to multiply it by 1/2 and then add 1/2. So now it ranges from 0 to 1. So if it's that bluish color, that means it's. Oh, well, we have it on the lighting mode. So I actually just want to return float 4 lighting dot albedo and then lighting dot alpha. Okay, so that means So yeah, so no wonder we were having no specular lights, because the normal vectors are, well, they're not 0, because then they'd be like that periwinkle color. They're just well, yeah, the albedo is 0, but the normal vector wasn't. Because yeah, if it's black, that means this normal vector, something weird's going on with it. What about it? Okay, let's just do the input and not deal with this normal map and everything. Okay. Still black. Interesting. So that means, yeah, I've got something very wrong here. So I can just put anything in this normal and it will transfer through. So let's set this to 1 just to make sure that like my debug scheme isn't bugged. So it should all be white now. Okay, so that's good. So that means this blade normal is like some weird value, because it's not 0, because then it would change into be that periwinkle blue. But it's like either extremely negative or like not a number or something, which I guess could happen if something here is giving me a 0. Now when we know that the wind is still working, because it's still like moving with the wind, so get wind offset isn't bugged. Let's see. Let's pass in this, I guess, this blade tangent and see what that looks like. So it doesn't go through all that math. Okay, so the tangent vector at least has values. I'm not so sure if they're good values or not, but so this yellow means that red and green are close to 1 with very little blue. So I guess that, I mean, some of this is pretty light, but so what should we not see? We shouldn't see very much red, because they shouldn't ever like point upwards. Which I think is true. Yeah, and then, okay, so what I was thinking is they don't change with the wind, but yeah, we don't recalculate a tangent vector. Maybe... So if I wanted to have another tangent vector, I guess I would do another cross product. But we already know that doesn't work right now, so... Well, let's leave that out. Okay, so let's maybe output... I don't know how useful this value will be, because it's probably going to be nearly black, so I guess I'll normalize it. Okay, that's an interesting effect. Okay, so it seems like it is like following the wind pattern. see, so I'm trying to think. Like this blue means it's kind of facing upwards, but the pink one is mostly red, which is along the, like, they're in world space, so it's it is kind of interesting that it's like this pure black, but that might just be, I think it might not actually be black. Well, I have implemented this before, so I can go and check my code real quick. Okay, so the bitangent is the same pattern. It's interesting on farther LODs. Yeah, nothing happens. But I guess that makes sense because the other LODs are just a flat plane, so. Alright. Let me check. I guess I might as well check my other script real quick. I'm not sure what. I don't really want to show it on stream because I'm not sure what or what state it's in. So let me see here. Okay, yeah. So I get a position. Yeah, just like this, where we add in, or we just modify the position. And okay, so then I get the original tangent and the bitangent, which we've done here. And then I get this offset based on the position plus tangent multiplied by a small number. And then the same thing, and then, okay, so yeah, well, one thing I do wrong is, yeah, here the tangent space needs to be this. Well, I was kind of saying it before, so let's see. Three. Something like that. Yeah, I don't normalize it. I guess I can use the same value. And then I normalize it here. I don't think that really makes a difference, but okay, let's try see what this looks like. Oh. Yeah, that's accidentally deleted that C there. So for better or for worse, seems like the code is about the same, but still not getting anything in the normal. So let's see. I wonder. I wish that there was some way I could print out the values, but unfortunately, with a shader, there's not a good way to do that. I have a feeling that there's like a division by 0 or something. So if this is 0, then there would be no movement or no difference based on the bitangent. So if the bitangent is pointing upwards, then yeah, that might actually be the problem, because if it's pointing straight upwards, the wind only, or won't perturb on that direction. So how can I How can I fix that? Yeah, so if these are the same, I kind of want the bitangent just to be itself, like, or like if the wind offset was 0. Then that would mean, oops. Oh, well, no, it'll actually, yeah, it won't be 0 because we are subtracting this bitangent nudged by the position world space. So unless the offset there is 0 as well, then yeah, that part won't be 0. That was an interesting thing though. Like if I turned off wind, then it might be possible for there to be, well, yeah, there wouldn't be any change. So in that case, would there'd be a division by 0, right? Okay. I think I might know what's wrong. Yeah, I'm gonna change these functions a bit. Let's make something that's just modify position. I think I was thinking about this slightly the wrong way. So what I need to do is start from this value and not like the unmodified position or the undeformed position. And that's because, oops. So that way if the offset is 0, then we are still adding this small direction along the tangent or bitangent. And I think that might be where this problem was coming from. What do we want to do? I guess we'll call it deform because that's what I used. Okay, so maybe this will fix it. Undeclared. Oh. I have it right there though. Oh, right here. Yeah. Oops. Guess I should rename that. Okay. Alright, there we go. So now we're getting colors again. Is it what I want? Like, they're not changing with the wind, really, but... also, okay. I was gonna say, I thought sometimes, like, if you're using a noise texture for wind, I notice sometimes if you get like these weird like wiggle artifacts, it's because the texture is compressed. But I thought I saw that, but I think it was just because I was really close to it. I don't see any like movement in the normal, which is a little bit surprising to me, but maybe it's just not visible because it's so slight. What happens if I increase this distance? Alright, I still don't see any change across the blade. I'm still using the normal. Well, yeah, maybe it's just slight. Let's, try. When I tested this on my other project, you could definitely tell a difference. Yeah, based on the specular color. Although, I don't really notice much here. If I, although yeah, at least we are seeing the specular color though, I'm just realizing. Because yeah, before we didn't really notice it. Let me see here. Change if I increase the smoothness to make the specular color a bit, or not as strong. Yeah, it's not shimmering. So what should happen is the specular highlight should like move and disappear with the wind, but it doesn't seem to be affecting it at all. So that is a little disappointing to me. Oh, is it? No, I have normal strength on. Oh, that's funny. When I turn the normal strength off, though, specular highlight goes away. Well, not all of it. I wonder why that is. Because when I turn the normal strength off, the normal should just be not affected by the normal map, but it would still be pointing straight out from the blade. But I might have to look into that a little more. Let's see. Let's test that out. Maybe that will help us figure this out. So I'll use the normal that's calculated from the normal map. I'm gonna have to. I guess I can do this a little simpler. Okay, so these normals will be in world space. All right, so blue means it's pointing in the positive Z direction. Yeah, so this is doesn't look correct to me because I don't see any dark blades of grass, which you would expect because some of the normals should not be pointing like, all in the positive X and Z coordinates. What if... I don't think there's a super easy way to do this, but I was wondering like if I make all the blades point in the same direction, that'll be easier to test. So if I go back into this and just, I guess I could have done it in here and set the twist angle to 0. Yeah, this probably won't, well maybe it will. Because we pick a kind of random tangent vector. Okay, so actually, yeah, they all are pointing in the same direction, so that's kind of nice for testing. So that's interesting. On this one, we can see that the curvature is affecting the grass. Oh, that's true as well. The curvature doesn't affect the normal. So in order to fix that, in order to do that, we'd have to basically we'd have to do this tangent to world matrix for these other two deformed positions. Oh wait, no, that's not true, because we put in the bin matrix into this tangent to world, so yeah, so it's multiplied into this terrain normal. So yeah, never mind. That's all. It's all in the normal already, which is probably why it's actually visible here, because it doesn't seem like my math with the wind is actually working. I guess I can make the wind like super... Yeah, maybe I should try that next. Make it extremely strong, and then maybe it'll perturb the normals a little more. But one thing about this is that the normal vector it's very tinted blue, which means it's pointing... Well, no, that's right. So it's in the Z direction in world space. So yeah, I guess that's true. I mean, that's correct. And it gets darker as the grass bends because the vector starts pointing upwards, which is less blue. So I guess it's actually turning more purple. Although, shouldn't it be turning green? Because it should be pointing... It should be like starting to point upwards. But I mean, we pretty much know this part is right. Alright, so if I passed this through... Oops. They should all be like green, like pure green. Which it is. So that's good. Okay, so it's probably fine because we know the terrain normals, right? Although wait, yeah, it should be perturbed by the curvature too, so let's test that. So I guess as it moves upwards, it should I don't really see any... Oh no, it is turning more blue because it's starting to point in the Z direction, which is... Yeah, I'm facing in the Z direction. Although maybe it's just getting darker. It's kind of hard to tell. I guess I could just see the Z direction. Let's do float 3. I feel like the Z should always be black because it's curving along the Z axis. Okay. Oh yeah, but it's gonna be this periwinkle color because I've remapped it to range from 0 to 1 instead of -1 to 1. But it doesn't, the good thing is it doesn't change. So I think that is right. So if we try the Y, oh, well, that's what we already know. Well, I guess we can see if it darkens, which it should. Okay, I'm kind of confusing myself. Let's... wonder if I can't do that. I was gonna say I'll change this remapping so it looks a little bit better. So why was it blue before? Because I guess because the Z was negative. Yeah, I'm confused. Right, because this is just the red coordinate, so why is it like this? So okay, I guess this just means there's very little red, so the z must be negative here. Yeah, because it must be something like very little red and then a lot of blue and green, or I guess exactly 0.5. So why, for the terrain normal, why is z negative? I guess it's the curvature. Okay, let's go back to here and I'll turn. Yeah, I'll turn off. Oh, I bet. Yeah, we have this normal map that's perturbing the terrain normal, so that might be it. Let's just make it point straight up. I should have done this earlier. Okay, so here. Oh, why is it black now? Because terrain normal Z. They should all be 0, so it should be that neutral, like, or it should be like neutral gray. Maybe it was. Let me. So if I add this in, is it gonna mess up again? Maybe there's some more math. Okay, so what's it showing me now? So it's showing me the blade normal. Oh, okay. Yeah, I still have it like unpacking the normal map, which probably didn't help with my previous test. So let's just bypass that. It doesn't make a difference for this part. Okay, so this is just the terrain normal. Yeah, which should be light green because it's pointing straight up. So I guess kind of tested this. So it does get darker. Alright, so now let's go back to try out. If I just passed in the z coordinate. So what do I expect? Yeah, I should get some. I should get, yeah, neutral gray because 0 should be, or the z should always be 0 and then the other two are 0, so. Alright, so that's fine. Now if I give it x coordinate, we should see a bit of reddening towards the tip. Or yeah, bluing is fine too because it's going negative, I guess. So negative x, yeah, it is to our left. Yeah, so that's actually fine. Okay, so that is working. Thankfully. Alright, so the blade tangent in this case, or the blade normal. So the x. So we should see a, or I guess it mostly should point. Okay, so this isn't what I was expecting, because the normal should point outwards from the blade, so it should be either like very blue because there's not much X, or very red because the X is positive. But instead it seems like X is 0. So let's try Z and see what shows up. Nothing. Okay, so is there a problem. Let's just pass in the actual, or I guess we already tested this, but I forget what it looked like. Oh. It's probably because it wasn't normalized, actually, now that I think about it. Yeah, because it's going to be really small. Okay, so yeah, that was it. It wasn't normalized. Okay, so since it's very blue, I think this means that red is negative. Which makes sense. Okay, and so the Z we should get neutral gray here because the Z should be 0. Yeah, so that's good. Okay, and I'll test Y as well. So this should change. Yeah, so as the blades curve upwards, it gets more green. And it gets even more green when you. So that all works. You can see when they start to turn over on themselves again, the normal vector is correct then as well. Okay. So that's good to see, but it's still like not changing based on the time or based on the wind, which is a little annoying because I'm not sure what I've done wrong here. Okay, so we already know this terrain normal is correct, so the bitangent is correct. Let's check out the tangent. Oh, except I wanted this version of it. Let's see. Float 3 modified blade tangent. Okay, so periwinkle. All right, so I'm passing in the tangent. So this means. All right, well, isn't this just the. Is this the default normal map? Which means that it's just pointing along the Z axis. Like it's that periwinkle color. So it's like 0.5, 0.51. Which means that the blade tangent is 0, 0, 1. So it's pointing along the Z-axis, which... Okay, so if the normal is on the Y-axis, then yeah, so that's right, because it should point along the blade. Yeah. And so it should be a constant color because the curvature... Yeah, the tangent vector doesn't change with the curvature, so that is right. Alright. Trying to visualize all these vectors. Okay, so this stuff is all correct. So something is wrong still here because it's not changing with the wind is the main issue. Because yeah, what should be happening is as the wind gets stronger, these values or like this normal should be becoming more green, because when the wind blows it flat, the normal should point upwards towards the sky. So why don't I turn or just increase the strength, maybe? Okay, well there it's doing stuff. So maybe it's been working this whole time, but I just the change amount was too small to notice. Okay, so I guess let's change that. Okay, so it turns. Okay, so when it moves one way, it turns green, and then the other way, it should turn like anti-green, which I guess is yellow. Yeah, so it seems like that is actually happening. Okay, so I guess this has been a good lesson in reading normal vectors, but I think, was it working all along? I just feel like the effect isn't strong, very strong at all. Okay, well, that makes a big difference actually. So I increased the scale of the wind noise, so now it has like more change within the grass blade. It looks kind of like seaweed now actually. Okay, so let's bring back in the normal lighting, I guess. And do I still have? Yeah, I have on specular mode because I want to see. Okay, so yeah, the specular light is changing with the normal. Okay, so I guess it is working. It just wasn't as pronounced as I wanted. But it's good to be sure. Okay, there we go. So now you can see. I mean, yeah, it looks like seaweed. It's actually kind of cool, but yeah, you can see um, the specular highlights every once in a while. All right, so if I change this back to be a little smaller. It just doesn't look natural. Maybe I'm just being too picky. Alright, because you know what? Oh no, it is supposed to be world. Right, it's supposed to be in world position. I was gonna say, like, maybe those normals, are they're not in, are they in tangent space, but I think they're in world space, so never mind. Oh, I'm looking at the wrong shader. Okay, anyway, so that was a fun little trip with math, but okay, so what else do I need to do? I feel like there was something I was about to do. Oh yeah, I need to turn back on the twist angle. Let's see. Right there. Okay, well, that's looking pretty good. I think, yeah, mostly I need to do better grass texture, I think. I'm not sure. I don't know how much I'll work on that because I don't like... Oh, I think I know what's going on there. because I don't really know how much people would want to see Substance Designer tutorials on my channel. But oh geez, culling is still messed up. But yeah, so there's this weird thing, and I think it's because the normal only points out along one side. So I think there's a way we can fix that. Let's see here. So if we want, basically for grass, we'd always like the normal to be pointing in the general direction of the player. So that, yeah, so the light affects both sides the same. So basically, here. You can get something called the facing. I think it's like, I think it's V face. Is that right? Yeah. So, and this semantic you can get in the fragment shader, and this will be -1 if it's the back face of the grass. So if it's, so we can just multiply both the normal and the tangent by this, and it will flip it if we're on the counterclockwise face. So now, yeah, all of the, oh no, not there. Oh, am I? Okay. That's not the issue, is it? Because, yeah, we have, yeah, the thing is, we need to like take the dot product with the view direction, and then if it's like negative, then we need to flip the normal vector instead of doing this V face thing. Yeah, because we, like I said, we want the vector to always face kind of towards the player. So what I can do, thankfully we already have to get the view direction, so this isn't going to be that big of a deal. Okay, so float 3 view direction world space. Alright, so float normal sine equals sine dot view direction world space input dot normal world space. And if, okay, so if these are parallel, it's going to return 0, which I think will mess everything up. How do I want to fix that? Well, let's just, I mean, that would probably, it definitely could happen. But I just want to see if this strategy will work before I worry about that. Undeclared. Oh. Okay, no, it doesn't, because, or does it? No, because there's still like the dark side, and the thing that's causing this is because one side's getting lit by the sun, but then this side's only getting lit through the subsurface. And it's because our normals are flipped. Okay, so what's the actual good way to deal with that? I mean, I guess, because the subsurface should be applied like when the normal is opposite of the light direction. So maybe that's what I need to do, is do the main light and not the view direction. Okay, let's is that right? Okay. Maybe the better way to fix this is to actually fix it in the lighting algorithm instead of trying to mess with this. Because now, let me think. Because basically what I've done here, I take the max with the subsurface strength, but that's not quite right, is it? Because it's like if the let's see. So it's if the view, like if we're viewing, or if the light direction is, or the light is shining through the object, we want to use the subsurface strength. So it's kind of like if our view direction is okay. So the light direction, I think, points from the surface to the light. So if the view direction and the light or the dot product is positive, that means the subsurface strength would be higher. Okay, so let's... And then I think I'll make this... Maybe the dot product should be... Well, I guess the surface side, which is an... Well, the thing is that both sides are technically the surface, so... Let me think. Let's see. Half, I guess diffuse. So basically we want to take like the absolute value of this because we don't really care what side of the normal it is, I think. So I guess I don't have to do saturate in that case. So the grass would then be darker if like the light is at like parallel to the grass blade, I think. So if the normal is close to the light, I think. So I think this is good. So the subsurface strength is if we're viewing... So, okay, I think I need to use this kind of like a mask, but only apply it if the normal and the light direction... Oh wait, that's... if the view direction and the light direction are parallel, I think. Let's see, half light and view dot... and then, okay, we don't have the, oh yeah, we do have the view direction. I guess let's flip this so that it's symmetric with the previous line. Okay, so in this case, we're seeing our seeing the light from through the grass. So in this case, we need to like multiply this diffuse value with the subsurface strength, I think. So that would be like diffuse equals 1 minus saturate the light view dot times the subsurface strength. Okay. And then yeah, I need to change that. Okay, so let me think here. I feel like, well, I guess let's just see how it looks. I don't know if this is actually going to fix that problem though, is the thing. Okay, well it definitely looks different. Okay, actually all the bases look the same, which is good. Okay, so why are these tips dark? Oh, I think it's because the subsurface strength, when it's 1, right, let's see. When the subsurface strength is 1, that means that we want light, but I'm subtracting, so this is kind of awkward. But I think I need to do that because, yeah, when subsurface strength is 0, then we want to mask it out. Okay, so when this is 1, we want... okay. Maybe... okay, maybe I think this was the issue, maybe. Let's see what that looks like. Okay, it's kind of like how it was before. Oh, also, we're not... you know, one thing about seeing the grass through the sun is also it's only if the light surface or the light is, or if we're in between the light, which I'm trying to rotate. Okay, well that's not looking nice. And I assume that goes away if I move around, and yeah, it's based on the light and then the dot product. Okay, so the thing is, this subsurface lighting should only come into effect if the dot product is negative, I think. Otherwise... okay, well, I think this absolute value of the dot product is the right way to do it, because it just means that so basically whatever side the normal is on, it doesn't really make any difference, because for grass, the back and the front should be the same. Yeah, so it's these blades that are turned like oblique from the sun that should get dark like that. But why is it flickering? That's not... it looks like Z fighting, but I'm gonna... if it goes away when I turn off the wind, then it has something to do with our normals changing. Okay, yeah, so it's probably just because those normal vectors aren't super high quality. I don't know. Unfortunately, yeah, we can't really fix that. But you couldn't really tell before. I think it's just now because they're dark. Maybe, let's see. Maybe I need to do like the maximum then between this diffuse and the subsurface strength. Okay, that's looking pretty good. Yeah, I think that's not too bad. Let's see. So it's a lot darker over here, and I think that's just because I have that dot with the light direction and the view, which doesn't really work because we need to get we would need to know like the viewer's position and then also the light's position, which technically we could get, but that makes things a lot more complicated, so I don't know if I'll worry about it. Alright, so now I'm kind of going back to my original algorithm, huh? Except just we use the absolute value of the normal vector. But it looks good, so. Okay, so anyway. I think I'm fine with this. Let's, yeah, we can, I mean, there's a lot more you can do. Subsurface scattering is a pretty complicated thing, but I just want something kind of simple for the grass, and this way we have a little bit of like translucency, but then we can also still get the nice specular highlights. Okay, I guess, oh yeah, the normals were off this whole time. Yeah, it looks better with normals on for sure. Because yeah, they when you have them off, you can't, the specular highlights are kind of just clumped together on a single blade, but when you have it on, I tried to like randomize it, so I think it looks better like that. We can, so I need to always make sure that it still looks good when you rotate around. Okay, so it's pretty uniform, although it seems like it's a little darker on this side. I don't know, it might just be my imagination. Let's see. I don't want to smooth this out low because yeah, the specular highlight is much too strong. Okay, so definitely brighter over here on the base. So when it's dark at the bottom, that tells me that it's relying on the specular highlight or the subsurface strength mostly, instead of using the grass normal, but I don't know why it's like that, because we're just using light direction and not like a position or anything. But it seems to definitely be on one side of me. Oh, did I leave in something to do with the view direction maybe? Oh yeah, I still had this flip. I I don't think we have to do that anymore because we took care of it within the grass shader. Oh. Or within the grass lighting, I mean. Okay, yeah, now it's more uniform. And when you look down... Okay, so there's some grass that has a darker base, but it's mostly because it's angled from the light direction and not because it's like just happened to randomly have a normal vector that's pointing the opposite way. So I think that is fine. Okay, so we're done with that. About 15 minutes left. So the last thing I need to do for this tutorial really is try to get it to work well with Unity terrain, and in order to do that I need to make another version of this soil shader that uses a height map. So I think I'll just copy and paste these files to start with. Okay, so let's do grass soil height. And so how this is going to work is, so this shader or this technique with the grass projecting the camera projecting the grass needs like a special shader for the soil, but unfortunately it's really difficult to write custom terrain shaders in URP just for a bunch of different reasons. So I think the easiest way is going to be to like put another mesh underneath your terrain and then apply the same height map to it, and that should and then what we're going to try to do here is make it so it'll spawn the grass on top of that height map, which should put it on top of the terrain. Yeah, it is a little unfortunate because you can't like use Unity's built-in tools to like paint grass on terrain, but I guess here's a little sneak peek for our future tutorial. I'm planning to cover that too sometime after this. We'll make our own grass paintbrush. Anyway, so for this we'll have them. So the main texture, I guess we'll still have that, but then we have, I guess we'll have a tint texture, but instead of the normal map, we'll have a height map, and we can just generate normals from height. I guess for some reason, I mean, you might want to still have a normal map, but I think if people want to, they can add that in. All right, so normal. I guess we need to have an altitude. Everything else, I think, stays the same. And then here I just need to include our other height. Our other HLSL file. And then in here, we'll just change this to height map. Okay, and then altitude. Okay, so this is basically going to be the same. Although, yeah, this clip is going to be different now because I think we'll have to, well, I guess the clip dimensions are the same, but we won't be able to use this position culling because we're gonna need to get the height from the height map. So yeah, this will have to calculate per fragment now. I'll just add that there so I remember. All right, so let's just make another function, float, get height. I guess the UV we would actually calculate from. I'll just leave it like this because we're gonna want to be able to get like adjacent UVs. Return sample texture 2D LED height map, sampler height map, just the red component. Okay, so let's see, float 3 position world space equals input dot position world space, and then we need to set the Y to get height input.uv, and then the float 3 culling position clip space is that, and so we can pass this into these values. Okay, so I think from then on we can kind of go on as normal. So we got the snap positions. Oh, this isn't. Okay, so that, yeah, I think earlier in the stream I was like, how come the density isn't affecting our debug view? And that's why, because I had left like this line in there. But anyway, that's an aside. Okay, so this is fine. So we check the density. So the terrain normal we can't use anymore, which I guess that means we don't even need to pass the normal and tangent actually. Or do I? No, I don't have to. Okay, so I'm gonna make another function to make this easier. So, do I need to get the tangent space for anything? I guess, yeah, because I need to have the train tangent and bitangent for the scatter effect. And then, yeah, I'm gonna need to get this tangent toe. Oh, I don't need that vector or this anymore because I'm not using a normal map actually. Okay, so void get tangent vectors. Okay, we already have the float or the height for the center position, so actually I need the whole position. Because I need to basically we're going to do kind of the same thing that we did for our grass blades to calculate a new normal vector, but this time we're going to do it by sampling the height map. So another thing I need here is the texel size for the height map, which is like the size of one texel, or which is a texture pixel in UV space, and Unity will give that to you automatically if you define a variable that looks like that. Okay, so yeah, we're gonna have to sample the vector. So we need to sample the height map on the x and y position, or wait, yeah, the x and y axis, but in both the negative and positive directions. So let's do float left equals get height UV plus height map dot texel size x, but only on the u coordinate. It also needs to be negative. So then right is positive. And then we have up and down, which is the y. And well, it doesn't really matter, but I think down is technically negative and then up is positive in texture space. Okay, I need to negate that. Okay, so now to get so I need to okay, so these are the heights. So I need to turn them into vectors and then take the cross product. This is going to be kind of verbose, but okay, so float 3 left position is center. Okay, well, it's actually moved to the left. Okay, so that's kind of interesting because I have it. Do I need a tangent to world space? Because I actually need to transform. Yeah, I think I do, because this is giving us height. Or I guess I could just make it faster and just say that it's going to always be axis aligned. Because yeah, I don't even know if you can rotate Unity's terrain now that I think about it. Although, would it be useful if I let you be able to do it in this one? Okay, because if I do that, then I'll have to have a tangent to world space matrix, because I'll need to know how to transform these like these positions in texture space into world space. But it will slow things down. But I guess I'll have to think about that. But anyway, so either way, we need to know we need to know like the size of one texel in world position, which to do that I need to know like the dimensions of this, which I don't know the easy way to get that. Yeah, I'll have to think about that. Yeah, unfortunately, I'm out of time, so sorry to leave you on this cliffhanger, but this is actually a kind of interesting topic, so I might make a separate tutorial about it in and of itself. But I feel like we got a lot done today, besides that silly bug near the beginning of the stream. But let's why is it not like that? Matching one parameter function. Oh yeah, because I'm packing stuff into the UV, so there's no just UV. Oh yeah, and this should also be a flip 4. Okay, well I kind of wanted to get everything into a runnable state so I could have it on the background during my outro. Okay, there we go. But anyway, so yeah, thanks everybody for coming by and watching. I really appreciate it. We'll continue this. Oh, hey Skylar Hawkins. Yeah, thanks for watching. But yeah, we'll continue this probably Monday. My goal is actually I wanted to get this tutorial ready for me to start writing the script this weekend. So we might do something else on Monday. I don't know. Depends on how much free time I have. But yeah, thanks everybody for coming and watching again. I'm sorry, I'm repeating myself, but yeah, I stream every Monday, Wednesday, and Friday at 9 p.m. Eastern. Also, on my YouTube channel, I put videos live on noon Eastern, so feel free to check that out. I'll put some links in the chat if you enjoyed the stream and would like to chat with me on Twitter or Discord. I try to be pretty active. But yeah, I guess that's it. So I hope you all have a great weekend, and I'll see you Monday. Bye-bye.